as another trick question. Whew, okay, let's get into it. A cricket ball and a tennis ball move horizontally. Hey, okay, having a picture in my mind, visualizing the thing. So they move horizontally towards an arm or a hand, so they're gonna get caught. And they move at the same momentum. Same momentum. Right. The mass of the cricket ball is greater. Right. And you apply the same force in stopping each ball. How does the time taken? So like same force. Should be no, same net force, right? How does the time taken to stop each ball change? So let's look into this. So you're given that you have the same momentum, right? If the same momentum is observed in terms of this, then think about it. The collisions that the ball and the hand are going to have are going to be quite similar, right? What do I mean by that? If you have the same initial momentum, you will definitely have the same final momentum. Telling you that for sure, right? What do I mean by that necessarily? So specifically, what do I mean by that? What do I mean by you'll have the same final momentum? So in terms of collisions, think about this. The momentum of the hand that's catching the ball, the initial momentum of the hand, it's going to be zero, right? So since the initial momentum of the hand is going to be zero, let's do that. So let's look at the collision of just one ball, right? Because the collision of just one ball is gonna, be the same as the collision of the other one. So let's say the cricket ball, and it has momentum, an initial momentum of x, right? So if it has that, um, we consider the mass of the cricket ball and the mass of the other one, and the mass of the hand. So what goes on with that? Well, we don't. Let's say that the mass of the hand is, you know, um, k, and the mass of the cricket ball, mass of the hand, mass of the cricket ball, is p. Velocity of the cricket ball is q, and the velocity of the hand is 0, right? So this is the initial velocity, by the way. The final velocity, let's make it r, and the final velocity of this, well, still going to be 0 actually, right? So if you were to write the momentum thing, you have your m, let's say mc vci plus h plus vh, I is equals to m CVCF plus MH VH final. Now for the cricket ball, we have determined that the initial momentum is x, but since this one has an initial velocity of 0, you just say 0 over here. Now the initial velocity of the hand is also 0 again, right? Just gonna come and say 0 again. So if this is 0 and this is 0, what does this have to be? Is that the change of momentum of this one also has to be what? Exactly, x, right? Now since this is x and this is x, and the other one is also x and the other one is also x, that's the kind of predicament that you're going to end up having. And now most likely your change in p is going to be 2x. Hold up, let's prove that. Change in p final minus p initial, right? So your p final is going to be right. So that being said, the consideration of this would then have to be that your change in momentum for the cricket ball is the same as a change in momentum for your tennis ball. So in your equation, you have F net is equals to, let's say F net change in P is equals to change in momentum. So if this is the same for cricket ball and tennis ball, and this is the same for cricket ball and tennis ball, wouldn't that also mean that this is also the same? There we go. Henceforth, your answer is C.